So we are proceeding on to the Gauss-Seidel load flow analysis, and I want to keep everyone's attention on what we were discussing on our last class. So for that we have gone through what is the need of the load flow analysis and why do we need a load flow analysis, or why are we analyzing our power flows. Then for the load flow analysis, first step we have already studied. We have to find out the single line diagram. Then from the single line diagram we are creating impedance diagram. Then from the impedance diagram we can form an impedance matrix or an admittance matrix. For load flow analysis we are using or we are employing this admittance matrix because of the many advantages of the admittance matrix. Admittance matrix is very easy to find, and we can represent all the elements using our admittance matrix. And usually admittance matrix is a symmetrical matrix. It is a sparse matrix, so it helps the computations to be very similar. And unlike the impedance matrix, impedance matrix require an impedance building algorithm to form it, but here if any modifications is required in case of admittance matrix, it is very easy because only we can add or remove the corresponding matrix elements, that is Yij or Yij and Yji. Since it is symmetrical, Yij, if an element is added to ith or jth, thus only that thing has to be modified. We don't have to find out the entire system, or we don't have to solve the entire system. So these all advantages enhance the use of admittance matrix. So we know how to calculate admittance matrix, and we have done some problems in class. Also I have given you a video referred, that was an IIT video by Professor Dr. Debriya Das, who was solving different types of admittance matrix problems. Now we are again back to our load flow equations. So last class from the equation, that is we formed from a 3-bus system, we formed an admittance matrix. Then we have written the equation of that particular system, that is I1 is equal to Y11 V1 plus Y12 V2 plus Y13 V3 plus etc Y1 and Vn. This was the equation, and from this we have found out that I can be written as sigma n is equal to 1 to n Yin Bn. And we also know the apparent power or total power, we can notate it as S I is equal to Pi plus JQi. So that can also be written as Vi into Ii conjugate. This Ii conjugate we know because of the direction. So is equal to Ii into Vi into Ii conjugate. So here we have the equation of Ii. So what we are doing, instead of Ii conjugate, we are substituting the equation of Ii here. So in order to find out Ii, I am taking conjugate of this particular equation. That is Si conjugate is equal to Pi minus JQi. That is equal to Vi conjugate into Ii. So Ii is Pi minus JQi by Vi conjugate. That should be equal to sigma n is equal to 1 to n Yin and Vn. Okay, now here we are solving load flow equation. Suppose we are having how many buses? Suppose I am having an n bus system. So if I am having n bus system, then we know each bus has 4 parameters, isn't it? And these parameters include voltage angle, then angle of voltage, that is delta I, then it will be active power component and reactive component of the power. So each bus has 4 components. So 4 into n bus, we will have 4n variables. That variables can be controlled variables, like we can control our power, controlled variables, and can also be uncontrolled variables, and also state variables. Usually this PQR we can control it. That is, if we are Pi is equal to active component of ith bus is equal to the power generated minus the load or demand. We can write it as Pi ith bus. Suppose we are considering, we are connecting and we have a generator and a load in a ith bus. So in that case, the total power emitted will be equal to the generated minus the demand power. The rest it will be given outside the system. So that is Pi. And similarly Qi also, I can say that is the generated power minus demand power. Now we can control this generation. We can control. So we can call it as a controlled variable. Okay. So we can call it as a controlled variable. But this demand depends on the load side or dispatch side. So some people switch on some devices, some people switch on the motors, air conditioners and all those things. We can't control them. So this can be, demand is uncontrolled. We cannot control our demand. So we can classify this as, this is a controlled variable and this is an uncontrolled variable. And there are other variables, that is Vi and delta I. Vi and delta I is the Vi and delta I. Vi and delta I, we call it as state variables. Depending upon the power generated and the load, this V and delta are changing. So we can consider it as state variables. So we have, for a bus we have 4 parameters. That is, here if we are having 4 buses, we have 4n equations. 4n variables are there, so we need 4n equations. But for us, depending upon the different types of buses, we can say for each bus 2 parameters are given and the rest 2 we have to find out. 2 it is given and the 2 we have to find out. So we need only 2n equations. Okay, so 2n we have variables and 2n we have to find out. Okay, in this case usually our entire buses will be load buses. Generators are very negligible in number. So around 85% are or 90% are load buses. So we will get P and Q in a system. Then we have to find out the voltage and angle delta. So our state variables are V and delta. So we are solving this equation to find out our voltage and angle delta. That's why I said this power flow analysis is essential for finding out the best operation. So after solving this power flow analysis, we will get the voltage at each node. From that, if the voltage value can be analyzed and if the voltage value is very less, we can classify it as a weak bus or a weak point. Then we can employ some compensators like capacitor banks, etc. to enhance the voltage there. So this power flow analysis is used for such kind of activities, future planning, what should we do for future extension and all those things. So we know now. I told all these things to make you understand that in a power flow analysis we are getting our solution firstly for V and delta. So I hope you understood why we are saying for V and delta.